In this video, you're going to learn how to solve a radical equation when there's a rational expression under the radical sign. So for example, we currently have the square root of x plus 2 over x minus 3 equal to the square root of x plus 4 over x plus 1. To solve this, you first want to square both sides. That gives us x plus 2 over x minus 3 equal to x plus 4 over x minus 1. Then you want to cross multiply. So we have x minus 3 times x plus 4 equal to x plus 2 times x minus 1. Distribute, you get x squared plus x plus a negative 12 equal to x squared plus x minus 2. Then if you subtract an x squared from both sides, and subtract an x from both sides, you are left with a negative 12 equaling a negative 2. In this particular situation, you cannot have a negative 12 equaling a negative 2. Therefore, there is no solution. In other words, this radical on the left side will never intersect this radical on the right side. But let's take a look at one more. What if we have the square root of x plus 1 over x minus 2 equal to the square root of x plus 5 over x minus 3. Again, square both sides, and that gives you x plus 1 over x minus 2 equaling x plus 5 over x minus 3. Cross multiply, and we end up with x squared plus 3x minus 10 equal to x squared minus 2x minus 3. Subtract an x squared from both sides. And you end up with 3x minus 10 equal to a negative 2x minus 3. Add 2x to both sides, add 10 to both sides, and x comes out to be 7/5. Now if you simplify what's underneath this radical, now let me backtrack a step or two. Let's check our answer, see if this is really a solution to this equation. So if I plug 7/5 in for x, I will notice on the left side I get the square root of a negative 4. On the right side I also get the square root of a negative 4. This is what we call then an extraneous write that just a smidge better. Extraneous root. Because if you really think about it, if you examine this left side, just examining one side, if x happens to be less than or equal to 2, or greater than a negative 1, if, repeating that, if x is anywhere between a negative 1 and up to and including 2, you're going to end up with the square root of some negative number. And there's a similar argument for the right side. Now, if x happens to equal 7/5, well then that falls between a -1 and 2, and therefore you're going to end up with the square root of some negative number, hence giving you this extraneous root.